Imagine that the very fabric of space around you is being stretched and squeezed by a trillionth of a millimeter. Too small to feel, yet powerful enough to alter the rhythm of distant stars. And if we could hear gravity itself, the universe would produce a constant, impossibly deep hum, the lowest note ever played.
This is the central mystery of modern physics. What is this strange hum? And how did we finally learn to hear it?
Of course, space is silent. Sound can't travel in a vacuum. But if our ears could hear gravity itself, translated into frequencies we can perceive, this hum would be the deepest, most chaotic bass note imaginable.
To find the answer, scientists didn't look for a sound. They looked for a clock. They turned their attention to millisecond pulsars, the collapsed remains of dead stars that spin hundreds of times every second, emitting radio beams with the precision of atomic timepieces. By timing 68 of these clocks scattered across our galaxy for over 15 years, researchers looked for the slightest hesitation in their rhythm. This answered the first small question. We can use the stars themselves as a giant stopwatch. To be clear, these ripples are unimaginably tiny. They stretch the entire distance between Earth and a pulsar by less than the width of a single atom. Yet pulsars are so precise that we can detect exactly that. Then scientists noticed something strange. The clocks weren't just drifting. They were all drifting together in a specific, haunting pattern. This created two much bigger questions. What is powerful enough to interfere with the most precise objects in the cosmos? And why is it happening to all of them at once?
The deeper they looked, the stranger it became. Scientists realized the interference wasn't a glitch in the stars, but a ripple in reality itself. When a gravitational wave passes through the Milky Way, it physically expands and contracts the distance between the Earth and these distant pulsars. This means the ticks of the cosmic clocks arrive a microsecond early or late because the fabric of space is wobbling. However, the real mystery had only begun. While a single collision of black holes creates a sharp chirp, this signal was a constant, low-frequency roar coming from every direction simultaneously. This presented an unexpected possibility. We are listening to a cosmic graveyard. The primary suspects for this hum are supermassive black hole binaries, pairs of titans, each billions of times the mass of our sun, locked in a death spiral at the hearts of merged galaxies. As these monsters orbit one another, imagine dropping thousands of stones into a pond at the same time. The ripples overlap into a constant, chaotic shimmer. That shimmer is the gravitational wave background. That wasn't the most shocking part. For the hum to be this loud and omnipresent, it means there aren't just a few of these systems. There are likely billions of them spiraling together across the observable universe right now. The stakes were suddenly much higher. If the universe is this crowded with colliding giants, our entire understanding of how galaxies grow must be fundamentally incomplete. What they discovered next changed everything. While billions of black holes can explain the volume of the noise, they cannot explain the entire signal. When researchers filtered the data, they realized that buried underneath the roar of the black holes, there might be a primordial signal, an echo from the first trillionth of a second after the Big Bang. Previous assumptions held that the early universe was a silent, uniform plasma that blocked all signals from the dawn of time. But gravitational waves are different. They can travel through anything, meaning this hum might be the only direct probe we will ever have of the universe's birth. This builds toward the biggest implication of all. In June 2023, the Nanograv collaboration revealed the unmistakable mathematical fingerprint of this hum, the Hellings-Downs curve. This quadrupolar signature proved that we aren't just seeing random noise. We have successfully built a galaxy-sized gravitational wave detector. We are now witnessing the cosmic microwave background of gravity. But the intensity of this hum is far greater than what our most advanced theories predicted. This creates maximum suspense for the scientific community. Either the universe is far more violent than we thought, or there is a type of new physics occurring at the beginning of time that we have yet to name. Most astrophysicists suspect the answer is violent, but ordinary. More merging galaxies than we thought. But a small, thrilling possibility remains. The hum could be revealing physics beyond Einstein. The strange hum is the gravitational wave background. It may be the collective symphony of supermassive black holes. And possibly, buried within it, the faint echo of the Big Bang itself. Scientists detected it by turning the entire Milky Way into a single, massive antenna. And here's the quiet implication. If the universe is this active, this violent, this noisy in the language of gravity, then our maps of the cosmos are missing billions of invisible events. Every time you look at the stars, remember, you're floating through a symphony you just learned to hear. If the very fabric of space is currently screaming with the energy of 1 billion colliding monsters, and we have only just developed the ears to hear it, what other invisible forces are tearing through your body right now, completely undetected?